Let's look at how to implement an important digital logic component called multiplexer. Multiplexer lets us choose between multiple inputs using a control signal. And today we'll look at 4 different ways how you can implement multiplexer in Verilog. In this exercise, we have to implement 2-to-1 multiplexer, or you can also call it MUX. And in this exercise, when select is 1, we have to choose B, the input B, and when select is 0, we have to choose the input A. And in this exercise, we will look at ternary operator, which is one way how you can implement multiplexer. And the way you do it is you write assign and your output, and then you write the control signal. In this case, it's called cell. And then you write the option when select is equal to 1. So in our case, select is equal to 1, then we choose B. So we will choose B. And then if select is equal to 0, we choose A. So the ternary operator, if it's equal to 1, it chooses this option. And if it's equal to 0, the control signal, if it's equal to 1, then we choose this option. And if it's equal to 0, then we choose this option. So this is the simplest way how you can implement multiplexer. Let's submit. It was successful. Another one. This is the same concept, but in this case we have a bus which has 100 bits, but it will be exactly the same. We will use the ternary operator and we will write assign out equals select. And in this case, when select is equal to 0, we choose A, and when select is equal to 1, we choose B. So again, B, A. And let's look at the next one. Next, we have 9-to-1 multiplexer. And in this case, we will not use ternary operator, but we will use always block and case statement. In this exercise, we have 9 inputs, A to I, and control signal. And if this control signal is between 0 and 8, we select one of these inputs. And if it's over 8, if it's 9 to 15, then we set all of the output bits to B1. So let's look at how we can implement this. First, I will create the always block. Here we have the sensitivity list. In this list, we put all the signals that if one of the signals in the sensitivity list changes, then the always block will be run. So in our case, since this is combinational circuit, we want to put asterisks, which means that if any of the signals changes, we want the always block to run. After that, we will create a case statement. So I'll put case, and we want the select to select one of the cases, and then end case. So the first case will be if the input is, if the select or the control signal is 0. So I will do it like this. So if it's hexadecimal 0, then we set the output to be A. And then we need to copy this 9 more times. I'll just wait a couple of more times. And we set these to B, D, E, F. Okay. So if the control signal is 1, then we select B, and so on. 4, 5, 6, 7, 8. And then we need the default case. So if none of these cases, if the select is none of these, then we go to the default case, and then we set all of the bits to 1. And we don't want to write something like this and then bunch of ones. 16 times 1. So we can just write, either we can do 16 and then hexadecimal 4 Fs, or you can also write just this symbol and then 1. And this will do the same. This will just output all ones. So let's submit this. And we can see it was successful. Next, we have 256 to 1 multiplexer. And if we would like to write all of the cases for 256 inputs, that would take a very long time. So what we can do is we can index the input, and I will show you how you can do that. So you write assign out, and then the output is just 1 bit. So we select one of the 256 bits using the select, and the way we do it is we just write in, and then we index it. And this way, the way you can choose one of the inputs. And finally, the last multiplexer, it's also 256 to 1 multiplexer, but the output in this case is not just 1 bit, but it's 4 bits. So let's look at the description. If select is equal to 0, then we should choose the 4 least significant bits, so bit 3 down to 0. If select is equal to 1, then we choose 7 down to 4, and so on. And in this case, we can use, I will show you what I mean. We can use the vector indexing as we have done last time. So we can do this. Something like we want to choose, for example, if select is equal to 0, 3 down to 2. So we would write something like select plus 3 down to select. And if select is 0, then we would do 3 down to 0. But actually, this is not valid. This will result in error. But what we can do is we can use another type of indexing. And this is called, if you look at the hint here, this is called index vector part select. And it was introduced in Verilog 2001. And I will show you the syntax for this. We write assign out equals, and then we write in, and here we write the start index, then we write either plus or minus, and then we write the width. What's the width of the output we want to assign to? So in our case, we write output to be, the start will be just select, but if the select is 1, we want the start to be 4. If the select is 2, we want the start to be 8, and so on. So I will multiply this by 4. So 4 times select will be the start, and then we want to add, and we want to add 4. So because the width is 4, right? So 0, 1, 2, 3, that's 4 bits. So I will write plus and then 4. So here we have the starting index, then we have plus or minus, whether we add to the index, to the start index, or we subtract from the starting index. And then we have how many bits we want to add or subtract. And you can use this syntax to implement the last multiplexer in this video. And we have and there is a error, I forgot semicolon. So today we looked at 4 different ways how you can implement multiplexer in Verilog, and I hope you enjoyed, and I will see you in the next one. Bye.